Welcome to Spring LIB.
Okay. So we have acetic acid and aniline in a flask. Okay. The way that we're going to separate these is the fact that each of these can be transformed into a charged species through the addition of acid or base. Acetic acid in the presence of a base will yield a carboxylate, and if we did lithium hydroxide, for example, we would have the lithium salt of acetic acid, right? And if we take aniline and react it with an acid, we can protonate it, and whatever the conjugate base is would form the salt there. The idea being that if we do this now, this is water soluble, and this is water soluble. And that if we react our mixture with a base, the aniline will remain in its neutral form, but the acetic acid will become charged. And if we react the mixture with an acid, the aniline will turn to its charged form, while the acetic acid will remain in its neutral form. And whichever is in its neutral form is going to be soluble in organic solvents, right? Now, it is important to note that aniline is a liquid at room temperature, right? So its melting point is like -6C. So at room temperature, we basically can assume that if everything's neutral, we've got acetic acid in aniline, right? So let's start. Okay, this is our beaker. We have acetic acid in aniline. We're going to add, let's say, aqueous sodium hydroxide. Okay, so suddenly our beaker, or really our SEP funnel, okay, is going to have our aniline, which is slightly more dense than water. All right, O for organic. Okay, and then I'll write A for aqueous. I'll write AQ for aqueous. And our aqueous layer, which should be on top because it's lighter technically than aniline, we will now have a carboxylate salt of acetic acid. And we can extract organic layer. Okay, so now we'll have our organic layer of purely aniline. And in our SEP funnel, So we're saving that off to the side. But in our SEP funnel, we've now got a purely aqueous layer of our sodium carboxylate, sodium salt carboxylate. From here, we can acidify excess HCl and diethyl ether. All right. And if we acidify it, remember we're going to put acetic acid back in its organic form. And its neutral form will prefer to be in our organic layer, where we will have sodium and salt, or sodium and chloride. And once again, we can extract organic layer, and we'll have acetic acid in our organic layer.